Okay, so in today's lesson, we're talking about temperature and how we can use it to shape plants. Last week, we talked about how light and temperature have an interplay, right? So light makes sugar and temperature controls the rate that the sugars are burnt. In this lesson, we're looking at using temperature to shift where the sugars are burnt and how that impacts how the plant grows. And obviously the background picture here shows tomato seedlings that are compact and short, and ones that are long and sort of leggy. That's basically what this is about. And I'll link it back to poinsettias briefly at the end because they're a classic crop, and there are some links in this week's folder which I'd recommend you have a look at that talk about using DIF in poinsettia crops and in bedding plants. But they're used there; it's used everywhere. So let's get into it. So in a greenhouse, we can control things with temperature in terms of we can control the actual temperature, right? Set a temperature, say you want it 20 degrees Celsius, it's 20 degrees Celsius. But we can also control the duration of that temperature. So how long do we want it at a specific temperature? And just like the last lesson, we can also link light to temperature. And so these are things that as growers we have to take advantage of to control our crops. So something I introduced last week was the daily average temperature, right? Just like I did the DLI, the daily light integral. So you've got your daily average temperature. That factors in both day and night. So if you have a daytime temperature of 20 degrees C for 12 hours and a nighttime of 10, your average for the day is 15. And today I want to talk a little bit about DIF, right? That's the difference between your day and night temperature. So, and then of course linking light levels like last week, but I'm going to leave that out for now. That's temperature versus light intensity. We'll address that a little later because obviously as light levels drop, there's things that we shouldn't necessarily do. So just to remind you that temperature and light have a sort of an interplay. And of course, sugars are made during the day when the sun is shining. But the key thing here, and I'll ask this on the midterm, make sure you know it, is that sugars are consumed 24 hours a day, right? So nighttime consumption of sugars plays a big role in how plants grow. So think of it as like during the day, the plant goes to the grocery store, loads up with groceries, and at night, the plant is busy cooking up dinner and feeding itself. Let's never used that analogy before. It just popped in my head, but maybe it helps you. So nighttime is when a lot of growth happens. Oftentimes, we see a lot of real stem growth and stretch happens in the morning before the sun comes up. This is another look at calculating daily average temperature. So here we've got a heating system that's trying to maintain 22 degrees Celsius during the day, and then at night it's dropping down to an average of about 18, and then it's back up again. So sort of a typical graph. This is probably more realistic of a greenhouse. By the way, the last graph was from the cannabis bunker, which, because it's not a greenhouse, it's fairly steady. Although the heating system's not as precise, you noticed it sort of fluctuated plus or minus 1 degree, which is not that bad. Anyways, in this greenhouse, this is actually a screenshot from Jeffrey's greenhouse, Jeffrey's greenhouses, the one on Lake Street, where the yellow line is our actual temperature measurements, right? And the blue line is our temperature targets as set to the computer. And so you can see the greenhouse is sort of reacting to these set points. It can't follow them exactly. For example, say we're going from this temperature down to this one, it drifts a little bit off the line. The sun is starting to rise here, so there's some energy being brought into the greenhouse, so it's a little trickier to cool it. But this is just a typical chart showing our calculations here. This is our mean, your average. So in this case, it's 15 degrees Celsius, daily average temperature. And you can see here's 15. That's kind of right down the middle. So what is the significance of daily average temperature? Okay, so as we increase the daily average temperature, so as we increase nighttime and day temperature, we increase the rate of node formation, which means more leaves, more branches, faster maturing, and faster flowering. And a modest increase in internode length. Keep that one in mind, because just running it warmer might seem a good idea, but there are sometimes a price to pay. In this case, it would be a stretched plant. Now, depending on the crop, this can be beneficial or it can be harmful. A lower daily average temperature, so that means cooler days and cooler nights, will decrease the rate of node formation, so fewer leaves, and they'll take longer to mature and flower, which is logical. This is kind of what we'd expect. And from a growth perspective, what we're seeing is also we get more root growth. So when we talk about shoot to root ratios, it reduces it, which means we're getting more roots. So that's great for earlier stages in crop production. Maybe not so much when you're trying to finish a flowering plant. This is an interesting chart. I don't know if Matt got into this with poinsettias, but almost all commercial ornamental crops have growth charts that they send out with cuttings, or you download them in grower sheets. And you'll see an upper limit for height at different weeks and a lower limit. And you want to keep your crop in between all the time, right? So that would mean applying growth regulators or playing with temperature. And this crop it dipped a little bit outside the height range. They brought it back, it went a little low, they brought it back, and now they've overshot the last little bit. It's a little bit too tall, but not horrible. So this is where a grower would put maybe flags out in a crop and go back and measure the same pots over and over again throughout the crop cycle. And then here you can see where they decided to apply growth regulators. You can see the correction. So here the crop is growing up. They apply the growth regulator, and it slows down and it starts to recover. They apply a growth regulator, and it starts to slow down and it starts to pick up. Whoops, that's a terrible line. And then it picks up again to here, and they apply a third growth regulator. And then at that point, it kind of just levels off, and then you're shipping it out. Now, if they had not applied any growth regulators at all, it may well have gone like this and off the chart. And you would have a really tall, lanky poinsettia that no one wants to buy. And if you remember back to my poinsettia lesson, the native poinsettias down in Mexico and whatnot are really tall, skinny, like branch things, and they're not what you're familiar with in a potted poinsettia. So that's a really extreme outcome. But so that's a growth chart, and that's where your daily average temperature plays a role. So you have the options of growth regulators, and you can also reduce your daily average temperature to shorten the crop. Now, if you reduce your daily average temperature, it's going to take longer to finish. So sometimes they don't have that luxury. Or sometimes your plants are moving too quickly, and then you can maybe cancel this growth regulator shot, cool the crop down, and it'll stay within the height requirement. Let's talk about DIF. DIF, what is DIF? DIF stands for difference. So it's the difference between day and night temperature. And then we'll also talk about evening and morning temperatures. But for the most part, let's just keep it simple and talk about the difference between your day and your night temperature. How you calculate DIF, and it's important you keep this consistent, you take the day temperature and you subtract the night temperature. Because whether this is plus or minus makes a difference. Okay, so keep this sequence the same when you're calculating it. So a positive DIF means a warmer day, and a negative DIF means a warmer night, versus the opposite. So in a positive DIF, your day is warm and your night is cold. In a negative DIF, your night is warm and your day is cold. if you're thinking about this, you might realize that negative diff would be difficult to accomplish at certain times of the year, like in the summer. So obviously there is some limitations about when you can achieve negative diffs. What is a negative diff, or what does a difference between day and night temperature do? So it affects how sugars accumulate in a plant. Basically how much and where the sugars go. Steering sugars is a really important tool in controlling plant growth. Your diff affects your net photosynthesis. So if you somehow slip off your daily average temperature, you may end up with sort of reduced photosynthesis, which means you have less sugars. That's where for example, in that poinsettia slide, it takes longer to finish because you grew it cool. So if you remember from Plant Science 1, plant hormones are distributed in the phloem. And of course, temperature impacts how sap in the plant flows. And typically it flows to the active parts. So whatever's still warm. So if something is warmer, it's going to get more of those plant hormones. So if the top of the plant is warm, the hormones are going to go to the top. So things are going to stay there and have their effect. Whereas if the top of the plant is cold and the roots are warm, things like cytokinin are not going to flow up as much. And you get less induction of branching, for example. Depending on the species. So again, this is the diff is talking about your difference between your day and your night temperature. Okay. What does diff do? All right. So if we increase the day versus the night, so if we make it a positive diff, we get stretched, we get taller plants, and we get larger leaves, and we have more photosynthesis. If we increase the negative, or the nighttime temperature, right? So we get a warmer night and a cool day, right? Warm night. Then the leaves are smaller and the plant is shorter. And part of that is you have more respiration, because remember, respiration happens all the time, and at night it's the only thing happening. And so if your nighttime temperature is warm, you're going to have more respiration happening, so more sugars are consumed, and the plant can't build big cells the following into the next day. So the plant actually lays down smaller cells and in a sense is smaller, more compact. This is what happened to me when I was obviously a baby. My wife's laughing at me. Anyway, so this chart, this shows obviously just a weird way to represent plant height. Anywhere from a 18-degree positive diff down to a negative 18 negative diff. That is really extreme. I think you're most likely going to be in down around these areas in reality. But there's a big difference in height here. So we're going from 12 inches to 14 inches, the 2 inches height over the plant. So there's definitely some control given to the grower. This is a picture of a petunia bedding plant. The one on the right was grown with a negative diff, so negative diff, and the one on the left with a positive. So you can see a pretty large outcome. And obviously people don't want to buy petunias that look like this. It hasn't even flowered yet when they get to the garden center. So this is the compact stuff is what people want. And this is a great way to keep bedding plants compact without spraying growth hormones. And then like the cover slide when we started, these are tomatoes grown under a positive diff versus negative diff. Pretty profound difference there. So diff also affects reproductive versus vegetative growth. I've mentioned this a couple times, and you'll hear it more in the winter as we talk about strategies with vegetable productions, but reproductive growth means more flowers or more fruit, and vegetative means more leaves. And obviously, if you just had fruit alone and no leaves, you would have hardly any sugar production, which would mean you're not going to get fruit. So obviously, you need to maintain a good balance of leaf growth versus flower growth. So that balance is critical. So as you increase the difference between day and night, plus or minus, this is either direction. So as the temperature variation increases, the plants produce more flowers and more fruits. As you reduce the difference between day and night, right? So there's less difference between your day temperature and your night temperature. Your plants are more vegetative. And this often happens when people are trying to grow flowering plants in a house, for example. They may not have a big difference between their day and night temperature in their house, and they may not get many flowers. Now, the biggest reason why they're not getting flowers is because there's low light in a house. But if they have a south-facing window, and they might say, well, I don't know, I'm not getting a lot of flowers, I get lots of light. Well, part of it might be that you don't have enough of a difference between your day and night temperature. Now, if it's right by a window, that seems unlikely because cool air is going to come off the window, but you never know. So that's one other outcome from DIFs. So the bigger the spread, the more generative or reproductive. The smaller the spread, the more vegetative, the more leaves you grow. I tried to create a chart here to help you remember. So this is DIF, and we're recording the direction of the DIF, so plus and minus, right? So warmer day, warmer night, a cooler night, we get a taller plant, bigger leaves. Warm night, cool day, we get a shorter plant, smaller leaves. And then as we increase or decrease the DIF, regardless of direction, right? So over here, if we have more DIF, it's generative. And if we have less DIF, it's vegetative. Now, using both daily average temperature and DIF, what can we achieve, right? So right off the bat, I want to be clear, this doesn't work really well on mature plants or slow-growing plants. So for example, you work in a nursery and you're growing boxwood bushes or maple trees, DIF's not doing much for you. But if you're growing fairly rapidly growing plants, like bedding plants, or our high wire vegetables, for example, tomatoes and cucumbers especially, peppers a little bit, the DIF has a bigger effect. But definitely at the youngest stage of plant development is where you see the biggest. Like remember the slide showing the tomato seedlings. Those are seedlings, fairly young, and had a huge impact. That impact is a bit diminished as the plant gets bigger. So oftentimes DIF is done at plug production facilities where we're growing young plants for transplanting. And then daily average temperature is our throttle for achieving a certain ship date. So we can control the speed of the crop's growth, kind of relating to last week. And it depends on what our objective is, right? Are we trying to get a perfectly shaped plant, or do you want to manage a balance between fruit and leaves, or do you want to have smaller leaves and bigger flowers, or do you want to have a shorter or a taller stem length? For example, cut flower growers try to achieve certain lengths of stems for quality standards. So sometimes they have to stretch those stems, and they can use DIF to do that. So minimal DIF keeps plants vegetative, accumulates the sugars, they stay in the leaves. They don't tend to move down to the roots because there's not a lot of temperature difference to encourage the sap to flow. So the leaves tend to get larger, thicker, and if we did a sugar analysis in the leaf, we'd see a lot more starch in the leaves. So we get a bigger, rapid increase in canopy size. But you can keep in mind, you can DIF for a day or two or a few days and then go back to normal if you want to make a change in your crop. Increasingly negative DIF, right? So night temperature is getting bigger than day. Plants become much more generative. They start forming buds. They start to build more biomass, more branching. The internodes are more compact. So some of these are really desirable traits. And the downside is that the flowers may form faster over a smaller canopy. That can be good, can be bad, right? But typically, and this is definitely a down, there are fewer buds and smaller flowers. So nothing in life comes for free, right? So you might get a more compact crop and save on growth regulators, but you might have a few smaller and fewer flowers. So that's what, going back to that chart, this is what this part is showing here, that more diff ends up with nice compact but slightly fewer flowers. And that may or may not be an issue. If you're growing bedding plants, as long as there's some flowers, you're good. They're not going to count how many flowers are on it. So you're saving a lot of money on growth regulators from having to spray all your bedding plants to keep them under control before you ship them. Combining negative diff with your daily light integral is also important, right? So your nighttime temperature obviously affects how sugars flow from the previous day's photosynthesis. And when there's days where there's actually very low DLI, so in the winter you don't have a lot of light unless you have grow lights, but let's say there's no grow lights. Oftentimes the plants don't produce enough sugar to grow because the sugar they do produce is consumed by respiration at night. So that's why through, November, December, early January, crops really don't grow a lot unless they have supplemental lighting because they're barely using the sugar or providing enough sugar to maintain their own respiration. And typically what little sugars they have, they've done distributing early in the evening. So it doesn't make much difference if you do negative diffs in the middle of winter. So why pay to have your greenhouse warm at night if your daylight integrals are very low the following day or the previous day? So be mindful of that. So with low light integrals, we have to apply less temperature increase at night. So we want to avoid that negative diff for the most part. As you get higher light integrals, you can do more. But in the dead of winter, not a really great tool. I can't remember what's on the next slide, but the other problem with the diff is obviously diff only works seasonally to some extent. So let's say the winter doesn't work so well unless you have grow lights. But the other problem is if it's in the middle of the summer, your nighttime temperatures aren't very cold. So you can't even achieve much of a reversal in temperature, right? You can't. So diff applies primarily to shoulder seasons, which is why we talk often about fall for poinsettias or early spring for bedding plants, because that's when the climate is perfect to use diff to control plant growth without having to spray a lot of growth regulators. But in the dead of winter, in the middle of the summer, not going to. So here we're looking at light accumulation. Your DLI is this red line. As the sun is shining, your DLI starts to accumulate, and we're not achieving a significant amount of DLI. And so temperatures are floating a little cooler. As you have a brighter day and you have a larger DLI, you can let temperatures float higher. It's a lot of scribbling, but I think you get the idea. So oftentimes your computer system automatically tracks and adjusts night temperature and your DLI accordingly. So that's nice. You don't have to constantly sit on it, but you should monitor it, check the graphs to see what's going on, make sure something's not wrong. One other thing about diff, if you change the F to a P, we call it dip. And this is probably, I would say, even more common than an outright diff. Partly because a bunch of us greenhouse guys are cheap, and the idea that instead of heating your entire greenhouse for the whole night really warm, what a few people started to find was that if you just did a drop in temperature in the morning, you could have a larger diff outcome, right? And that would help a couple of things. It would impact sugar flow, but it would also shock the plants. Remember, big diffs make plants more reproductive. So you could get them to jolt into flower a little bit. But as a diff, it basically allows you to sort of control some of the sugar flow and shorten the plants up a little bit. Anyways. It's a bit of counteractive because before this we were talking about, a pre-dawn dip. It would seem like that would be more effectively increasing a positive diff, right? But the reason why this shows differently or behaves differently than a full-on negative diff, where your warm temperature, let's say you have a nighttime temperature and you come into the day, and this would be a negative where it's warmer in the night and cooler in the day. The difference here is that in the morning is when a lot of the stem stretch happens, a lot of growth. Typically, if you think about it, cells are dividing during the night, and as the sun rises, those cells fill with water and they start to stretch. That's when roots start to drink and the stem elongates. And by cooling the air at this stage, when the cells are elongating, we can actually reduce the influx of water before the cells harden up, and we can actually keep the plant short. So it's a little counterintuitive to what a positive negative diff was. That's what we call it, a pre-dawn dip. We don't want to call it a diff because it's kind of got a different outcome. And the nice thing about it is that it works great in seasons when there's cold air outside, right? Because all you do is open your vents or open your curtain and cold air dumps from the top. If this is your greenhouse and you got your curtain, cold air is trapped up here. And then when you open the curtain or the vents, this cold air pours down onto your crop and shocks them with cold temperature. And you get this pre-dawn dip. Other options for plant height control that we've talked about, but might as well review them. Higher light levels, right? So brighter light levels. Limiting phosphorus. We talked about that in plug production. Water stress, withholding water, that for sure works, but you have to be careful you don't damage the roots. Mechanical stress is something I have not talked about. Mechanical stress is really interesting. If you brush plants with your hands, it actually causes them to react to that and stiffen their walls, which also keeps the cell walls from stretching, and so the plants are kept short. There's a greenhouse in Burlington called Aldershot that grows miniature roses, potted roses. And I don't know if you've seen the irrigation boom we have at the college. Matt's hopefully talked about that. He's not using it right now because it doesn't work well on poinsettias. But what Aldershot does is they drag a plastic bar under the boom as it rolls over the benches to irrigate them. And that plastic bar bangs against the plants as it moves along. And you might think, oh, that's going to damage them. It doesn't. It just gently drags over the plants, and that mechanical motion causes the plants to become stiffer, stronger, and more compact. And they've cut their growth regulator applications down, I think, almost by 75% by simply dragging these plastic pipes. They did different experiments. One of their houses has clear vinyl straps like you see in a cooler hanging on the boom as it drags along. Both work. The other thing we talked about was spacing plants, right? Don't be greedy. Don't put too many plants on a bench. Otherwise, they just compete for height. So typically what we try to say is we want to avoid leaves overlapping. As soon as one leaf overlaps another, the one that's been covered is going to try to stretch to get over top the other. And so you end up, your entire crop just starts racing for the sky and it gets stretched. Cooler outside conditions before transplanting or hardening off. That's possible, maybe more of a nursery application. From the lighting perspective, we'll talk more about this as we go through the program. But red to far red, you want that high red ratio to keep the cuttings compact. You'll notice the lights over our propagation bay have a lot of red in them, and that will help to keep plants compact in that area. You can also pinch, like on the poinsettias, but that costs money because you're paying someone to pinch, and pinching can be inconsistent. And then, of course, we've also mentioned growth regulators. Finishing up, I got an interesting slide here. This was a study done down in the States where they looked at using different temperatures, not so much diff between day and night, but difference between the zone. So this was what we call root zone heat. So they had heat right on the pots, and they had cool air temperatures. And what they found was as they raised the temperature of the root zone substantially, they were able to achieve a really interesting outcome. So looking at the finished product, it's almost identical to the last column, which is conventionally produced with growth regulators. This side has no growth regulator. So that's pretty cool. I I don't know that a lot of people do this because running really warm, like 27-degree root zone temperatures, costs money. So, anyways, just thought you might find that interesting since we've been talking about poinsettias. All right, lastly, finish up with this. As opposed to the pre-dawn dip at the beginning of the day, there is also a pre-night dip. And this is interesting from a tomato production perspective. This is common practice, especially in tomatoes. And I mentioned this in one of the labs at the greenhouse, where just before sunset, you drop the temperature of the air abruptly. And what happens is the fruit, which is thick and has lots of water in it, which has a high heat capacity, the fruit stays warm and the leaves and the stems cool off. And what happens is sugars will flow because of the warmer fruit. Sugars will flow from the leaves into the fruit. And that's how you make tomatoes sweeter from a commercial standpoint. So pre-night dip increases sugar flow to the fruits. So as the air temperature drops at the end of the day in the greenhouse, when you open your vents briefly, the sugars that are in the leaves will then flow to the more active fruit. So you got your leaf here, and then you got a branch with tomatoes growing. The sugars will flow to the fruit. Not sure why I drew that. Doesn't even look like anything. Okay, so we've talked about daily average temperature. We've talked about DIF. DIF causing, if you even have a difference, that it's more reproductive. If there's no difference between day and night, the plant is vegetative. And then we talked about pre-dawn dips and now pre-night dips. All right. Thank you.